In our next video for today, we're going to be talking about circumscribed angles. These are essentially angles that are going to exist outside of our circle, and then they're going to interact with it in slightly different fashions through things like chords, secants, rays, and lines that might be tangent or inside the circle itself. Let's take a look at our first example here. Listed down along the side right here, we have two different tangent lines. Each of these lines just taps the circle in one individual point and then ejects off into infinity. This circumscribed angle, which we have here, is going to be angle A, or more commonly called angle BAC. The way that we go about finding the vertex angle or the angle measurement for this particular circle is that we're going to take the value of the large arc BHC, subtract it by the actual arc from the inside portion of the angle, the one that's facing it just opposite here, and then we're going to divide it by 2 or just multiply it by 1/2. So in this particular version here, say we had a degree measure going all the way around of, say, maybe, let's do 300. This portion here, by default, is going to be the value that basically gets us up to 360, because we're talking about one portion of the circle, and then this other portion, which gives us the entire circle. So we'll say 60. We take this value, which is 240. We multiply it by 1/2 or divide it by 2, and we get a value of 120 for our angle on the side here. So this is just a general example of this angle right here. It's not going to be physically worth 120, but this is how we would go about quantifying it in a way. Similar to what you saw in your previous video, but different. We're adding this additional layer of subtraction. And this additional layer of subtraction, because now we're going from outside the circle itself. So we need another methodology in terms of quantifying it. What I want to show you is another example of this with slightly altered lines. In our next example here, instead of having two tangent lines, we're going to look at a secant and a tangent line. Your secant, if we remember back to our first lesson in this unit, is going to be a line which goes through a circle and doesn't necessarily make contact with the diameter. It just goes through one point and out the other, but it can exist outside. It's just a line that shoots through, or a ray that shoots through, but it continues on. Here we have line PR, which is a tangent, and if we want to go ahead and quantify that angle of RPQ, we're essentially going to be doing the same thing. What we're looking for are the two arc measures that we can interact with here, or that are formed by those intersections. In this particular example, we're going to go with the large arc, RTS, because it exists. It's a large arc between those two lines, those two intersections, and then we have our small value here of RQ. So we set up an equation, we find the degree measure of both those. Say, for example, since we're going past a little bit before the diameter here, we can say have an example of 140 degrees, maybe a small portion of 70. Subtract those two out and then multiply it by our 1/2, and we'd get a theoretical angle of, say, 35 degrees. Our next version, same exact process once again, but we're just using two secants this time, or two rays essentially. We take the value of the larger arc, subtract it by the small arc value, and multiply it by 1/2. What you might find in some of your examples when you're looking at it is that maybe these lines are like really close and they almost look like they're equivalent, like you don't know which one's the larger one, and that's all right. Theoretically, if we had like a value of 100 and say 80, we would get a value of 20 as a difference, multiplying it by 1/2, we get a value of 10. If we did the numbers backwards, say 80 and 100, we'd have basically -20 and then down to -10. We would know just to flip those signs. So if you do mess up the signs, it's all right, but you want to keep it going that way just in case you have more complex equations that come up in the future. To finish up with this video, we're essentially done with our notes. As a reminder, you can go on YouTube, pause, play, skip around, so you don't have to do so in Edpuzzle. What I want to do is show you an example question, what it might look like, and how we go about, say, solving for it. Here I came up with an example, and we're going to use this diagram essentially as a reference. So let's take a look at this first one. Here we're told we have an arc value of 80 degrees for QR, and then we're asked to find angle P. Way that we would go about solving here is we want to take circle G, which is theoretically 360 degree measure. We're going to minus that by QR, which is 80, and that's going to give us the value of QRS. So we can, arc QRS. That way we can set up that original equation that we're trying to work with. So if we do 360 minus 80, we end up getting a value of 280. And now we can go about doing this original equation, where we can say the measure of angle P is going to be equivalent to 280 minus 80 divided by 2, or, multiply by 1/2. Here we get a value of 200. We divide it by 2, and we get a final solution of 100 degrees. So as long as, just like our previous lesson, as long as we're following these rules, if we do it a few times, they'll start to just like kick in as a memory. Next, we're going to go ahead and do this other example. We're going to use the same diagram, but our numbers are going to change here. In this particular example, we're told that angle P itself is going to be 45, and then we're going to want to find the value of RQ and QSR. So you might be saying to yourself, how do we go about using these two portions here when we don't even have values? How are we going to get two different variables? One thing that's kind of cool, like if in theory, what our equation would look like is something like this, right? It's going to be the arc QSR minus arc QR, multiplied by 1/2, or we'll just say divide by 2. And I'm going to write it this way, and it'll catch up on in a second why. But we do know that there is some type of relationship along the top, and this is what's going to allow us to basically work with two different variables to come up with an actual value set. So let's try it this way here. This particular example, what I'm going to do is actually call the value of arc QSR as x. What that's going to allow me to do now is set up an equation where I know if I take the value of x, And then I create a parentheses statement where I say 360 minus x is equal to QR, because we do know in this particular example that we have a circle of 360 degrees. We know if we subtract this amount here, our x, we would get this value. We can set that up inside the parentheses as a statement. The way that we go about next for actually solving for x and then eventually getting our arc measures is we're going to set up an equivalency statement, essentially. What I'm going to do is put this 45 over the value of 1, and then we're just going to go ahead and cross multiply. 45 times 2 gives us a value of 90. And if we are to multiply 1 times this top statement, it's just going to stay the same. The next thing we have to do is we need to take this subtraction sign into consideration. This is going to allow us to then pull out this value, combine like terms, and then set everything for 90 and just go ahead and solve for x. So I'm going to add my -1 here, and I'm going to say if I multiply -1 times -360, I get a value of -360. And if I multiply -1 times -x, I get a value of +1x. Now I have everything pulled out of my parentheses, and I can basically combine my like terms of 2x and -360 and just go ahead and solve it algebraically. So now we have a value of 450 equal to 2x, or what you would say is basically 225 as our value for x. The last thing we want to do here is that if we're going to go ahead and solve now for our RQ and our QSR, we're going to have to go in and basically push these values in. So our arc QSR is going to be equivalent to 225 because that's our x value. We now need to just find the value of our missing measure. To find our missing measure, we're basically just going to take 360 and minus 225, which gives us a value of 135 for arc QR. If we then wanted to check our work, we can do 225 minus 135 and then just divide out and see if everything quantifies out, which you can take a look there, and that's a difference of 90. 90 divided by 2 gives us our 45. All I want to show you for today is just these rules associated with circumscribed and inscribed. With your circumscribed, essentially your angle that's going to exist outside of your figure. What we're going to go ahead and do is basically find the difference of the two independent arcs, divide by 2, and that's going to be our angle measure. When we're talking about our previous material or inscribed, that's when we're just finding those values and dividing by 2 to get the angle, or if we're going from the angle to the arc measure itself, we're just multiplying by 2. So I'll finish up here with you. Last thing is for your work today, you're going to have independent practice questions. If you followed my recommendation, you only have like a handful of more IP questions left. Your exit ticket for today, I think, is about 3 questions. It just kind of relates to things that we just did right now, and you won't have any homework set up. So you'll have your whole weekend free. Just make sure that when you complete your exit ticket that you're going to upload a copy of your work as well to our class Google assignment. That way I can give you credit for both of them. And once again, if you ever have questions, please let me know. Come check in the office hours. I'll be more than happy to help you out. All right, well, I hope you stay safe. Hope everyone in your family is doing well, and have a nice day. Bye.